Now we get to problem 8 of the test for review. In the following capacitor setup, the question says, find the charge stored in the 8 microfarad capacitor, which is this one, and the energy stored in the 4 microfarad capacitor. It could ask us here a whole host of questions. You could say, what's the voltage of this? What's the voltage of this? What's the charge of this? What's the charge of this? What's the energy of this? What's the energy of this? Anything like that. So how do we go about this? Well, with this kind of a system, what we have to do is break it up piece by piece with the first thing that we see, and then we combine them. So what is the first set of capacitors that we see here? Well, these two are in series, and then once we find the sum of that, then we know that it is in parallel with that, right? So we do the series first, then we do the next step. So how do capacitors add up in series? 1 over C1 plus 1 over C2 is equal to 1 over C total. And this is series. So we say 1 over 8 plus 1 over 10 is equal to 1 over C total. And then that's equal to what? 18 over 80. And then we invert that. So C total is equal to 80 over 18, which is what? 40 over 9. So basically that's equal to the roughly about 4 and something, right? That's the capacitance of this. So it's better to write that in so we know where we are at now. So we have a 6 microfarad, and then we have here the equivalence of 40 over 9 microfarad. Then we have here 4 microfarad, and we have a 10 volt battery. Then these two are in parallel, so you do that next, right? So these two are in parallel, you go like this. And how do capacitors add up in parallel? Right? Well, they just simply add up C1 plus C2. So C total is C1 plus C2, and you end up with 4 plus 40 ninths. 40 over 9 plus 4, that's 40 plus 36 over 9, which is 76 over 9. 76 over 9 microfarads, right? And now, these two is our final step. So what are they? And so those are going to be in series, so we're going to have to reciprocate them again and add them up, right? 1 over C total is equal to 1 over 6 plus 1 over 76 over 9. Then 1 over 76 over 9 is 9 over 76. So we multiply them, we get what? 76 plus 9 times 6 is 54 over 6 times 76. So what do we get here? So what's the total capacitance? Then you invert these. You get 456 over 130 3.5077 microfarads. So the net capacitance is 3.5077 microfarad with, so that's the final circuit that we end up, right? With a 10 volt battery is connected to a 3.5077 microfarad capacitor. Now we start building our way back up. So we argue, what is the charge that this capacitor would store? So we got to start with Q is equal to CV. So multiply the net capacitance by the voltage, which happens to be 10 volts. So that would give you what? 35.077 microcoulombs. This is going to have a charge of 35 microcoulombs stored on it. This is the summation of these two being in series. We know that in series, the charge of two capacitors is the same as the net charge on the net capacitor. they store the same charge as this net capacitor. So each one has a charge of 35.077 microcoulomb. 35.077 microcoulomb. Now, if I want to know the voltage of that is going to be Q. So I take the charge, 35.077, divide that by 6, you get 5.846 volts. 5.846 volts. Well, we could do similar here. We could divide this by this and get the voltage of that. Or we could argue, since this is 10 volts, that means if this is 5.846 volts, the two of them have to add up. So 10 minus 5.846. 10 minus 5.846, and that gives you 4.154 volts. So now I know the voltage of this, 4.154 volts. Okay? Now, if I know that this is 4.154 volts, I know that these two are in parallel. Capacitors in parallel have the same voltage as the net capacitor that they are equivalent to. So if this is 4.154 volts, both of these are the same volts. 4.154 volts, 4.154 volts. Then once I know the voltage of each, I can find the charge of each, right? I can multiply the capacitance by the voltage. 4 times 4.154. Okay, so then the charge is going to be what? 4 times 4.154, then you get 16.616 microcoulombs. Okay, and then here the charge is going to be 4.154 times 40 over 9. 4.154 times 40 divided by 9, 18.462 microcoulomb. And it has to make sense because together, if you add the two charges, 18.462 plus 16.616, together they should have what? 35.078 microcoulomb. Together, they should give you the same charge that we found earlier, 35.077. We found earlier that these two have a charge of 35.077 microcoulomb, and it should actually come out to the same charge here, the sum of the two charges, okay? Well, what's left? Once I know the charge of this guy, I can argue this capacitor has the same charge of these two individual capacitors. This is the same charge, which is going to be a charge of 18.462. 18.462 microcoulomb, 18.462 microcoulomb. Answer for that, the charge of the 8 microfarad capacitor is 18.462 microcoulombs. There's always going to be some rounding in these kinds of problems, but more or less that is the answer to within about 3 decimal places. 18.462 microcoulombs. What's the other question that it asked? It asks, what is the energy stored in the 4 microfarad capacitor? The 4 microfarad capacitor. Well, we know that the voltage of that is 4.154 volts. We also know that its charge is equal to 16.616. 16.616 microcoulombs. So we could use any of the forms of the energy equation. The energy of the 4 is equal to half Q times V. So it'll just be Q is equal to 16.616 times the voltage 4.154. So multiply the charge by the volts, times a half. So you get 16.616 times 4.154 times 0.5. The energy is equal to 34.51 microjoules. Or you could say the potential energy of the core is half CV squared. So you would say half 4 microfarad. And then the voltage is 4.154 squared. So this one is actually easier. You just do 4.154 squared times, and then this is a 2. And you get 34.51 microjoules, which is the same answer. So whatever format of the energy equation you use, if you are consistent and you did it right, they should all come out to be the same answer, right? So 34.51 microjoules, and the charge of this is 18.462 microcoulombs. Okay, thank you.